Hello, everyone, and welcome to this Agile Business Webcast Series broadcast, Scaling Continuous Integration to Large and Distributed Teams. This webcast is brought to you by CMC Media and is sponsored by AccuRev. I'm Mitchell Funk, editor of Agile Journal, and I will be your moderator today for this webcast. In a few moments, Damon Poole will join us to discuss scaling continuous integration. First, I want to go over a few housekeeping details before we begin today. Our livecast environment is intended to be completely interactive, so you'll have the ability to post your questions at any time during the broadcast or chat with other attendees about today's session. You can use the live chat window directly below the webcast window, and you can also undock the chat box from the screen by using the pop-out button at the bottom right corner of the chat box. You'll see a little circle there indicating where that button is. That way, when you pop it out, it won't get hidden behind the slides. If you'd like to share your thoughts about today's event, you can use the Twitter and Facebook links above the slides to share, just up there. A tweet roll panel will show you today's active comments on the right. You'll want to use the #AgileLC hashtag in your tweets to get on the tweet roll today and invite others to join in today's presentation. If you'd like to get a copy of, excuse me, I forgot that is the tweet roll there to the right of your screen. And if you'd like a copy of today's presentation materials, you'll find a button to download a copy of the presentation and other files under the Resources tab at the top right of the page. A recording of the entire live broadcast, including the Q&A, will be available within 24 hours in the same location, so you can come back to the same page to watch it again or recommend the presentation to a friend. Last but not least, if you would like to expand the display and get a closer look at any of the slides during the presentation, just hover your mouse over the video player and click the full button to expand the full screen. It'll just pop up there when you hover your cursor over it. So now that we have the housekeeping details out of the way, I would like to introduce our speaker that's joining us today, Damon Poole, the founder and CTO of AccuRev. Welcome, Damon.
Well, thank you very much, Mitchell. I appreciate it.
Yeah. Damon Poole is the founder and CTO of AccuRev, a leading provider of Agile tools. He has 20 years of methodology and process improvement experience, running the gamut from small teams to 10,000-person global development shops. Damon is a certified Scrum Master and writes frequently on the topic of Agile development with an emphasis on multi-stage continuous integration. His do-it-yourself Agile blog is at damonpoole.blogspot.com, and you can also follow him on Twitter at Damon Poole. So Damon, we want to thank you very much for joining us today, and we look forward to a great presentation.
Thanks very much. I will try to give a great presentation. All right. So let's see here. All right. So one of the points that I like to cover before I get into the presentation proper is that sometimes I find that people are coming to learn about Agile because they want to learn the new terminology, right? So, it's like there's a different name for requirements. Now we call it stories. In meetings, we stand up. But at the end of the day, it's probably all the same stuff, right? But actually, no. This is not like going from C++ to Java. This is a very big and different kind of change. And to illustrate that, I wanted to give you the principle that comes from Agile called the simplest thing that could possibly work. And this is a concrete, pardon the pun, example for you, but this can be translated to software as well. So here we have 3 bridges. We're just going to talk about the 2 on the right. And my question to you, my mental question to you is, what is the name of that bridge on the right? Hold that thought for a moment. So the bridge on the right has a business value of being recognized as a Boston landmark. The one in the middle is just trying to get traffic from point A to point B and last a long time, not fall down, take a certain load, that sort of thing. All right, so the requirements are pretty much the same, except the bridge on the right is trying to be that landmark and have the business value of being recognized in Boston. So the question is, how much did these 2 bridges cost? Well, before we get into that, as I was putting this together, I noticed there's this thing on the right, which I would call a bolt-on, right? So why is that there? That doesn't seem right. It seems like they made a mistake. But actually, I was talking to a civil engineer, and he said that the reason for this was that they didn't want the eddies of traffic to mingle and slow things down, because the traffic on those two lanes comes in at a different point and goes out at a different point. So they didn't want them together. But my question to him would be, if I had, now that he told me that and I thought about it, my new question is, but why didn't you just make the bridge wider and use the concrete dividers that are already being used between the other 8 lanes? So in any case, this bolt-on makes the bridge even more complicated. The math is different, so that means it's going to be more expensive. This bridge is definitely not the simplest thing that could possibly work. The simplest thing that could possibly work would be to build 10 lanes just like the bridge in the middle. So in what does this have to do with software? In software, often we do not build the simplest thing that could possibly work. We try to take into account all kinds of future requirements. People might need this might happen, that might happen, they might need that. Wouldn't it be great if we could also do this, if we did this, all that kind of stuff. But most of the time, most requirements never get used. So that means you paid for it to be implemented, but you're not getting any value back from it if people don't use it. You could have built a version of the product that didn't have it in there. You'd get the same benefits out of it, the same revenues or whatever it is, for a lower cost. So it turns out that this bridge on the right is $11 million per lane. Now, if you live in Boston, you might think, hey, that's a bargain. But did it achieve its business objective? Do you know the name of this bridge? Most people say no. Well, it is the Zachem Bridge. So even here, it did not, get the business value of being recognized as a landmark. As an example, counterexample, the San Francisco Golden Gate Bridge, everybody recognizes that. So the kicker here is the simplest thing that could possibly work only cost $5 million per lane. Total savings here, $60 million that you could have used to do something else. Same thing in software. Agile is going to give us a framework for doing things in such a way that we're only spending a smaller amount of money and using the money that we would have otherwise used to go and invest in something else. So Agile definitely has benefits, and there's one concrete example. Okay, so we're going to be talking about multi-stage continuous integration, and to be talking about that, we really need to talk about what is continuous integration, what is integration. To talk about that, we need to look at the software development process. Now, I'm going to be talking about and comparing and contrasting to some degree traditional development versus Agile development and how continuous integration fits into both. So in traditional development, we have the customers giving requirements to product management or business analysts. They produce a document, which then goes to the architects. They do design, which produces another document, which is the plan, the architectural specifications, and then it goes to the managers that produce the plan, and then it goes to coding. Now, often we think of that coding stage as that's where Agile happens. But in fact, Agile goes end to end from the beginning of specification all the way to the delivery of the product. But we're going to focus now on the integration part. So if you've got folks coding for, say, 3 months, you might have them integrate all their work together at the end, or perhaps once a month. Usually people don't integrate more frequently than that, and that causes problems. Right? So you get this integration where things are coming together, and they don't necessarily work the first time, right? So we call that big bang integration. Once it finally works, we ship it off to the customer. Now here is an example of continuous integration. Every time a developer makes a change, they're going to check it in, and then they're going to take those changes from other developers back to them. Right? So it's just constantly making changes and integrating them back. So in this case, I have 2 teams. I have one team that has 3 team members and another team that also has 3 team members. So if they want to integrate with each other, they're going to integrate to the main line. So if somebody on team A makes a mistake, instead of just impacting team A, he's also going to impact team B, which is not necessarily so good. What could we do instead? Well, let's also look at the cost of this integration, right? So how many, in your organization for developers, how many check-ins do they do for a developer per week? Now think about that for a minute. A very low ball answer that I hear a lot is actually 2 per developer per week. Number of updates also 2 per developer per week. And 1 problem out of every check-in, out of every 2 check-ins, right? So once a week, 1 problem per developer introduced. And then how much time is it going to take per problem to resolve it? Right, so maybe I've got 10 people on the team, and I got 10 problems in there per week, and then they each take 30 minutes to resolve. It doesn't necessarily mean that it's 30 minutes for 1 person, but the whole team may be impacted by that problem. Each person is like, oh, is that my problem, and trying to solve it? Right, so clearly that's not going to scale well, because the more people you have, the more chances you have of a problem, and the more people you have, the more people that are going to be affected by that problem. And that actually scales as something that we know, which is n squared. Right? So it just gets worse and worse and worse over time. Now there are things that we do to counteract this, absolutely. But left unchecked, this is what will happen. Right? So you get basically for, in this example, 20 developers, 3 developers worth of time is lost. So what you can do instead, one of the things that will help, right, is in development, one of the things we often do is solve things with trees because they scale as n log n. But in any case, regardless of the math, you can see that if I create a stream or a branch per team, then integration can happen at the team level first, and then when that works successfully, integrated at the whole product level. Right now, purists with continuous integration would say, wait a minute, everything is always integrated to the main line, not, a branch or something. Absolutely, I agree. In this example, that branch is a transient state. You're just saying, I'm going to integrate this first ahead of time with just my team's changes, and if that doesn't work, why would I inflict other team members or other members on other teams with that problem? I'm going to solve it, and if there's a problem, I know it's just a problem introduced in my team, not anybody else. We're going to fix it, then move ahead. It's pretty much the same common courtesy that you give other developers when you check in. You don't check in every time you make a change. You check in after you've made a change. You've done some sanity checks, some testing, maybe you run all your unit tests to say, you know what, I don't think that this is going to hurt anybody. I've done a responsible amount of work to make sure this is okay. Same thing, but applied at the team level. So that's the basic idea of multi-stage continuous integration. So to give you a little bit more background on why this is important, let's take a look at traditional development and one user story that I want to get through the system. So there's this one user story. I've specified it up front, something like as a user, I want to take an online survey. As a user, I want to add a true-false question to a survey, something very simple. Right, so now I have the story, then I'm going to do the design. How am I going to implement this? Somebody's going to write the code, and then at some point, it will be integrated into the overall product. Right, so you may just do a check-in, but it's just on your branch or something, or it's not really ready to go to the end user, and this would be in traditional development here. And then at some point, there's documentation written, tests written, and then the tests are actually run. Right, so it could be a long time in between writing the code and actually somebody running a test or creating an automated test beyond just, say, unit testing. So in that case, right, a lot of problems can occur in between. So even in Agile, within an iteration, let's say this is a month, you can have the exact same problem. It doesn't really matter what the time is between when you write code and when you do the testing. If it's over a couple of days, you're just not going to remember the details. You're going to have moved on to some other thing that's going to be taking up all of your mental space for thinking about that. 3 days, 4 days, a week, 2 weeks, it gets harder and harder. So it doesn't matter that it's 6 months versus a week. A week is already too much. Right? So what can we really do? And if we're looking at a whole bunch of different stories going through this iteration, all of these individual stories have specification, design, coding, integration. Right? If you squint when you look at this, I've got this green specification phase first, then the design phase next, and then the coding phase. That looks a heck of a lot like waterfall. So my point that I'm making here is that continuous integration is one of the ways that you can make this visible and deal with it. Right? If you're not integrating continuously every time somebody does a check-in and it doesn't have tests associated and the tests aren't passing, right, then continuous integration is going to show that you have these problems. And I'm hoping that having you think about it this way, it will motivate you to do all of this closer together, much like if you have an escalation or a hotfix that you need to do, what gets in the way of getting that out to the customer? Nothing, right? Nothing does. When it's really important, the method that we use is something called one-piece flow. You may not call it that. You might call it get it out the door as fast as you can with high quality so that that customer stops screaming at us. Right? That might be what you call it. But at the end of the day, the method that people use when it is really important to get done quickly and accurately is do the steps as fast as you can, as close together as you possibly can. No delays in between. Right? So why don't we just do that all the time? But, without the running around with your hair on fire and having people scream at you and under great pressure. Right? So we'll do everything as a hotfix. We're going to do any specification we need, design, coding, writing tests, documentation, integrating, and testing as fast as we possibly can, one thing right after the other, no delay. And we're not going to start something new until we get that done. Now, it may be that you can work on a couple of things at a time, right? If you have 3 developers, you might work on 3 things at a time, but you're going to try to avoid working on multiple things at the same time. This is where continuous integration can really help us, give us feedback quickly, allow us to deal with the problem quickly, and keep us on the right track, getting high-quality software out very quickly. So, if you're doing Agile, you may have a task board which is very similar to sort of a traditional view here where I've got backlog, which would be all the things I need to do, which would be the things I'm planning to do this iteration, or in traditional, this release, things I've started on, things that are all coded or tested, and stuff that's even done. Right? It doesn't really matter what you call it. It's the fact that you have stages that's important. If you're going to have these stages, a great thing that you can do here, which is another kind of multiple stage continuous integration, where this is in one after the other, not in parallel, is associate a stream or branch with each stage of your process. Right? In an Agile process, it may be much simpler and things get done much quicker, but you can associate continuous integration with each of these. And so a story goes through this gauntlet, if you will, and by going through this gauntlet, you're assuring, or at least having a high chance, a high degree of likelihood that only stories that have made it to the tested stage, right? Stories that have made it to the tested stage only get there if any criteria that you've set are met, right? So, for instance, if you check in, that's work in progress. It doesn't mean you're done coding. Maybe you just did it to check it in and do a backup. But if I move it on to the coded branch, I am asserting that I am done coding. It's ready for whatever the next stage is. I can go on and work on something else. And if it makes it to tested, I am asserting that any automated tests that I need to have, I have, they've been run, and they pass. And then done would be a final step, maybe exploratory testing or performance testing, whatever your criteria is in your organization. But if I do that, that means that I can then, with continuous integration and having this association, I can build a version of the product that only contains tested stories. If you're using the mainline, you're not only going to have done stories and tested stories, you're also going to have things that are just being started, they're coded, but they don't have any tests associated. So imagine you're trying to demo a version of the product to your customer. You want feedback. You go to do it. You go to log in, and the login doesn't work because there's a story somebody's working on for a login that they've checked in, but they haven't, there's no official test. It worked for them, but it's not working for you. And that's what's important to you. Right? So if you do this, you have a way to build a version of the product that only has the stories in it that you care about, and then you can look and see, does this version of the product actually have the story I care about? So not just for demoing, but if you're an end-user documentation writer, you want to be able to take screenshots and actually use the product and see that it works that way. And if that story is not considered tested, why should you start documenting it? Also, if you're doing testing, if you're doing exploratory testing, why should you start testing on something that you're going to find problems that the automated tests could have found if they existed or if they had been run? So to get this association, you need something very important called a change package. Now other people, with AccuRev we call it a change package. Other systems might call it like a change set, a change list, excuse me, a depot revision or a repository revision or something like that. But you need this link between the stories or defects that you're going to implement and the files and tests that were changed or created to implement that story. If you have that link, then you can build a version of the product with just the stories at the stage that you desire. So, another important part of this is visualization. If you're doing continuous integration, multi-stage continuous integration, those multiple stages are going to correspond to different stages in your overall development process. And if you're doing traditional development, or even Agile, you probably have a whiteboard that looks like this with a branching strategy and all that for whatever branches you have. But now think about it. If you're doing what I've been talking about, and you're doing it in different teams, in different places across the world, that's a lot more to visualize. And if you've got different versions of the product, that's a lot more to visualize, right? And it's going to be a mess, right? So things break, questions go back, right? So it's not so much in this case that it's traditional development that's at fault, it's that our integration process, which is broken even within traditional development, is going to be worse in Agile because now we're trying to do it every month, every 2 weeks, even every week. So the question you want to ask yourself is, do you want that or do you want this? Now, here, this is something that we call Agile SCM, and part of Agile SCM is the visualization of the overall process from customer to product management to your master backlog to your team backlog to your teams, continuous integration at each level, multi-stage continuous integration for bringing various teams together, and then the final staging area that would then go off to the customer when you're ready to send it to the customer. So my PowerPoint skills are rather limited here. It's hard for me to visualize 80 Scrum teams in one picture, but we have customers that have 80 interrelated, interdependent Scrum teams all working towards a common outcome in a visualization that looks like this. Right? All those teams working together, some teams integrating up, multi-team integration, all the way up to the final product. And when that works well, you've got user stories, master backlog, all these things I talked about. And when it works well, it flows very smoothly. So the benefit here is you can think about the fact that if I have something that needs to be done and has high value, I can get it through this system without it being dependent on what things that other teams are working on or problems that they run into, all the way up to the mainline, integrated and ready to ship, so that I could ship it if I needed to, because there's business value in me doing that. But even if you don't need to do it at that extreme level, which many people are starting to do today, we have customers that go live into production multiple times per day using a setup just like this. These are not small companies. These are very large companies who are doing things like multiple $1 million of transactions, financial transactions, every day on their live systems. And so this is real serious mission critical stuff. To do this, you need something like Agile Cycle. Right? So we have two products. One is Agile Cycle, the other is AccuRev. Agile Cycle is a comprehensive suite which includes Agile Project Management for your backlog and user story management, which includes AccuRev SCM for Agile SCM, and Ansible Pro for your automated build management. So we also have, if you're new to Agile, we have a success workshop. We'll come in and help you understand where you are, where you need to be. We have Scrum Team user training, which is a one-day course, very reasonably priced, which we're doing in a couple of locations coming up. You can check out our website for that. And for all the information you might need about anything I've talked about today, you can see it here. So, now it's time for Q&A.
Thank you, Damon, very much for that great presentation. Remember, everyone, that we can accept new questions if you use the chat box right below the webcast screen there. So I believe we do have some questions, so I'll start off with the first one here for you, Damon. It seems that multi-stage integration requires a lot of merging. How should I handle that?
Okay, that's an excellent question. That actually comes up a lot. But I think what's happening here is by going over that material and showing you it in that form, it reminds people of all the merging that needs to be done, period. Right? So if I get a whole bunch of people working on a big development team, then if two people happen to be working on the same thing at the same time or near each other in time, they may interact with each other and you may have to do a merge or actually resolve a conflict. Right? So this doesn't actually reduce or increase the number of conflicts you're going to run into. It only increases the amount of merging that you need to do from stage to stage which has no conflicts. Right? So that's actually not that painful. That's just some administrative overhead that can be scripted around. So anything, the normal course of events would be I'm moving something from one stage to the next. I don't expect any conflicts just because it's moving from work in progress to coded. Right? Nobody's working on the coded branch. They're all working on the work in progress branch. Right? So all your conflicts are going to be at the work in progress level. If you have multiple teams, now instead of having the conflict right away between two teams, I'm going to have it, because we all check into the mainline, I'm going to only have it when I integrate from the team level up. But as I showed in the flow, you're going to be doing that integration very rapidly, so it shouldn't be that much more for waiting for that conflict to happen, and you're only going to have the same number of conflicts, and all of the trivial merges you can automate.
Great. Hopefully that really gives a good answer to the audience member there. We do have a couple more coming in now, so to get down to it. How often do merge conflicts happen with continuous integration?
I'm sorry, I asked that again?
I'm sorry. How often do merge conflicts happen with continuous integration?
Oh, okay. That's pretty much the same as the previous. That's just a sort of a subset of the previous question. So they happen as frequently as they would with mainline development.
Great. Well, that's a quick one, and it's good because we do have a new question that just came in. Damon, how would you suggest handling the merge conflicts when binary files are involved?
Okay. Well, that would be exactly the same as you have today, right? So if you have, if you're checking into the main line and somebody's made a change to a binary file, then you're going to have to resolve that conflict. What people usually do with binary files is they say, all right, there's really no merging that can be done here. I'm going to do serial locking so that if I'm going to work on this file, I'm going to lock it so that nobody else can work on it. That's one way. And then it depends on the kind of binary file that you have. If you have a binary file which is, say, a Word doc or an XML file, there are tools out there that will allow you to actually merge those as easily as a text file.
Okay. Next question here. One of the audience members asks, we already use a software configuration management tool. Can I implement continuous integration with my existing tool?
Absolutely. So continuous integration is independent of SCM. So if you've got something like Subversion or ClearCase or something like that today, you can absolutely go out and get any number of free or commercial tools to do continuous integration and build management. I think the appeal of using something like AccuRev in conjunction with continuous integration is that We make it so easy to do that integration. We make it so easy to set up the staging for you, such that when you get to the build, the only thing you're verifying is that at that level of the hierarchy, that it does integrate and work there. So in general, what we find is that using our product, people have to do fewer builds, and that's really one of the benefits of using our tool in a continuous integration environment.
Okay. Well, while we're waiting for some more questions to come in, David, if you want a chance to go over anything in the slides that maybe you'd like to expand on, you didn't get a chance to, we could do that now as well.
Okay, sure. So one of the things I was talking about is we have some customers that have very large implementations, some that have 20 interdependent Scrum teams, others that have 40, and at least one that has 80 that I've talked to. And it took them a while to get all that infrastructure set up, but you know, they already had all of the teams and all the people and all the pain, and what they did was they slowly introduced continuous integration. Various teams adopted it for their work. So even though they were only integrating once every 2 months or every 1 month, when they did that integration, all the problems that they could have found as a team, they had already found. Because when they did a check-in at the team level and it caused a problem, they fixed it right then and there. So they knew that when they moved their changes on to the next level in that month, the problems that they were seeing were problems of integration, not problems at the team level, if you will. So while it can take a while if you have a large group, every step that you take will make your life better and make that integration better. And continuous integration really is, you know, one of the ways of monitoring your overall health. If you don't have check-ins happening that frequently, continuous integration is going to show that. If you have builds failing all the time, continuous integration is going to show that. And one of the great things about having the multi-stage continuous integration is that you're focusing on breaking stories down to a small size, moving them from end to end as fast as you possibly can. And when you do something on a regular basis, very frequently, you get better and better at it. You find problems, you solve them. When you're only integrating every month or every couple of months, it's very hard to build up that proficiency and get better because the number of things you're looking at are very large and the number of changes you might want to make things better is very large. Plus, it's not really clear what's causing what problem in order to understand how to solve it. Okay. Anything else come in?
Well, would you like to poll the audience maybe to get some more information as well?
Sure. I think one of the things that would be interesting to know is how many people are using continuous integration today. How many people are doing multi-stage continuous integration today?
Okay, so we'll get that poll set up and pushed out to the audience here.
Okay, great. I think another point that got me thinking of as I was talking is that some of the older tools that are out there, it's a little bit harder to use continuous integration with them because what they're doing is they're constantly checking to see if there are changes and they're constantly pulling out files to do builds. And that really puts a lot of strain on the traditional tools. They weren't really intended for that purpose. Excuse me. So for instance, with AccuRev, we have features like the ability to register certain streams or branches, if you will, to be associated with continuous integration. So AccuRev itself will say, you know what, that check-in is in an area that you said you cared about. It may affect a build and require a new build. You should go and kick that off. And then what you have in that situation is instead of some of these systems that poll all night long to see if there are changes and there's nobody home, right? There's nobody working at that time. That's putting a strain on that system so that if somebody is actually working at that time, they're still experiencing the load of all that continuous integration going on.
Okay, it looks like we did get another question here from the audience while we continue. With your tool set, Damon, can teams merge end-to-end independently from other teams?
Absolutely. Yeah, absolutely. So the way AccuRev works is that it's through inheritance. So you would have, the root level, which basically all changes flow to, and then you have at the leaf level the individual developers contributing changes. So as changes move up, they get inherited at any level that can see those changes. So if you think of a classic tree, as it moves up the tree towards the root, other leaves are going to start to see those changes. So as they get merged up, as you move things up, you'll start to run into conflicts, and then you can resolve them at the leaf and then push it back down. And that's actually, you know what, that one's actually hard to say, to explain, verbally. That's something that I would invite folks to go and take a look at our website, maybe see some of the demos, and engage with us to get more information on how that really works. I have to say that one of the things that we find is that talking about AccuRev is one thing, but actually seeing it in action opens folks' eyes up, and they often say, "Wow, I didn't expect that an SCM tool could do that. I was thinking it was more maybe just like a tool that I already have, but faster, or a couple of cool new features." But AccuRev really is different, and you have to see it.
And again, we have the contact information and website information there on the last slide. Another question here, a longer question. What if change sets are dependent on each other? If the implementation of a story requires development by several developers, and developer A's change set is dependent on developer B's, how do we handle this in continuous integration?
Okay, that's an excellent question. So that one is multifaceted, and I'll try to answer a couple of facets of that, but that really deserves a much longer answer than I'm going to be able to provide here. So that's a problem that you have irregardless of what you're doing, whether you're doing traditional development, agile development, continuous integration or not. If you have dependent changes, that's going to make life difficult, right? So here I am in Team A, I'm working on something for a while, and it depends on something on Team B, and Team A is not going to be done for 2 months, and Team B is not going to be done for 3 weeks or something. And right there you have a mismatch in time frame, right? And then it may be that I'm not able to work on the next item until the other team is done because we want to see how that works, and then there's questions about the API. It's just a mess no matter how you cut it. So it's not that continuous integration is necessarily going to solve that problem, or that Agile is going to solve that problem. It's that it's going to create a framework for you to solve that problem. And some of the things that people typically do is they realize, oh, well, the reason for continuous integration in the first place is that people are doing short iterations. And when you have short iterations, your tolerance for problems is a lot lower. So when some problem gets introduced, you want to be able to find it as soon as you possibly can. The outcome of that is that you want to create stories that are as small as possible. So in the past, if we had a year to do a release, and we had something that's going to take us 3 months, we'd take the 3 months. We don't even bother trying to break it down into individual values. All right, so I'll give you an example. So here at AccuRev, we had a project of moving our system from a back-end database that was proprietary to us to Postgres, and that has completed at this point. And at some point in the development, a while back, we were in the process of moving to Agile, and one of the developers said, "I don't see how it is possible to break replication down, moving replication from proprietary database to Postgres, break that down into 1 month." We were doing 1 month iterations at the time. We're doing 2 weeks now. And I was involved with in that, and I said, you know what, you got me stumped. I don't know how to do that either, but I'm not as close to it technically as you are. And one of the other engineers said, let me see if I've got this straight. We want to break things down into smaller pieces of work that each have individual value for the customer. It's not that I'm going to do the back end and then do the middle tier and then do the front end. You're saying that I need to do something that the customer can actually use and get it completed in an iteration. Okay, well, I have a question for you. Would it be useful if we only did the receiving part of replication? We used the old database, the old protocol, to do the generation of the packets for replication. And I said, you know what, that is a brilliant idea. So what that meant we could do is it actually created new value. We could tell our customers, you know what, use your existing database for your production development work, create a replica which uses the new database, receives information from the old system, and if anything goes wrong, you can blow it away, recreate it, no problem. So you can test it, get a feel for it, how it performs, how it works, make sure it's good in your environment before moving to the new back-end database. So that's what we did in the first version of the product, the new back-end database. Worked like a charm, and by breaking it down that way, we had two user stories, one that took a month and the other one that took a month, and that was great. So just because you haven't thought that way in the past doesn't mean you can't do it now. By breaking stories down, you reduce the amount of work that has to be done that's associated with the dependency, so you don't remove the problem, but you simplify it. Now, where continuous integration comes in is that you're going to be moving these small stories up as fast as you possibly can and finding any problems that are a result of dependencies as fast as you can and then resolving them as fast as you can. If you wait for a month to do the integration, you're not going to find those problems as rapidly. And so it doesn't solve the problem, but it can help you simplify the problem and better detect the problem so that you can solve it.
All right, well, I'm glad we had some time for you to answer that long question.
Yeah. All right.
We do have a short one that just came in now. Should continuous integration happen for every check-in, or what frequency would you recommend?
Yes, that is actually, if you look in the Martin Fowler condensed dictionary on integration, well, by that I mean he wrote a paper called Continuous Integration. If you look at Martin Fowler's paper, and he sort of considers the father of continuous integration, he says that you integrate across the whole product on every check-in. Now, you might be thinking, oh, okay, that's all very well and good for this Martin Fowler fellow to say, but that's impossible on our project. True, I agree with you. It's impossible on your project today. However, many organizations that we've worked with over time get to the point where they can do it on every check-in, and they are able to deploy into a production environment multiple times per quarter, multiple times per week, and in some cases even multiple times per day. So, yes, that is the definition. Every time you do a check-in, you can do the whole product, build and test, get the results. Now, in reality, that can be difficult to do. But the main point of running a continuous integration is not necessarily that it completes all the way through if you have a 5-hour build and test cycle. It's that you find problems as fast as you possibly can. So one of the tactics that's used here is to say, let me rearrange over time all of my building and testing so that the areas that are most likely to fail, like say login, I'm going to run that build first, I'm going to run that test first, and it may only take me a few minutes to build a new version of the product incrementally that takes into account that change, runs login, and shows, you know what, you broke login. And I figured that out in like 10 seconds or even an hour. If it took you an hour to get that to that point and it failed, there's no point in running the other 4 hours of building and testing or the other 4 hours of testing. And maybe the building and quick and testing is very slow, right? So think of build and test, full build and test cycle across the whole product as your goal, and where you are now as your starting point. So it is hard, but the more you work towards it, the better off you'll be. And if all you do on that check-in, excuse me, is you run the smallest build you possibly can, maybe on just one platform, and you run maybe 20 tests or just some unit tests, there's value in even doing just that. And as you start down that road, I think you'll find more and more ways to do that. And there are tools out there like Anfield Pro that allows you to do a monolithic build and test that is run serially on different platforms and make it so you're running individual pieces on individual platforms and failing fast. That's what it's called, failing fast, and getting that feedback as quickly as you can. The principle of failing fast is any failure that I could have quickly, I want to get that quickly so that I get that information and go no further, fix the problem, and then try again.
Great answer. New question just came in. how does your tool cope with geographically distributed development teams? As an example, based on a central approach or distributed tool architecture.
Okay. Well, every copy of AccuRev comes with unlimited air travel. No, I'm kidding. Wouldn't that be fantastic? Excellent question. So in a geographically distributed environment, you have a couple of different problems. One is visualization. Where are people? What are they working on? And AccuRev handles that fantastically, right? So the way that we do that is we can help you visualize who you've got working on what team, how the teams are interrelated, and what projects they're working on, which releases, where you have hotfixes, service packs, all their interrelationships you can see, and it doesn't matter where they are. Right? So you can say, oh, there's the team in India, there's the team in San Jose, there's the team in Boston. Let me see what they've been doing. Hey, no check-ins all week. That's strange. Let me give them a call. Also, with multi-stage continuous integration, if each team has its own branch, remember, then that means the team in India or San Jose or exotic Boston has their own branch for doing their work with continuous integration, giving them feedback. So if I do a check-in before I leave, it fails, it's not going to go to the main line. The folks in San Jose are not going to see it. The folks in Chennai are not going to see it. They're not going to be impacted. It's not until I come back in the morning that I see the problem and fix it, and it's only impacted me. So multi-stage continuous integration in general definitely makes it a lot easier to do these things, and AccuRev makes it a lot easier to do multi-stage continuous integration and to visualize it and to integrate with the other tools that you need. And if I didn't fully answer that question, I'm not sure if I fully answered that question. If the person asking that question wants to do a follow-up, that would be great.
We look forward to the follow-up if, again, that did not answer the full question for you. And while we are waiting for the potential follow-up, Damon, any other advice you'd like to give those in attendance today? Sure.
I think one of the reasons people come to learn about multi-stage continuous integration is because they're also curious about Agile. And one of the things that I see a lot with Agile Teams is that they read a book or a friend of theirs has talked about it and they give them an overview or this PowerPoint or somebody comes in and does a half-hour presentation on how to be Agile and then they go from there. The fallacy of that is that going to Agile is not like, hey, I know C++ and now I'm going to do Java, or I know .NET and now I'm going to do Java, or one of those kinds of things. If you move from Java to .NET, you're not necessarily going to change your management structure. You're not going to change how you do work. It's just you're going to be using different tools in the exact same environment. Right? And I'm not saying you have to change your management structure, but often people do reorganize management to fit a more agile perspective. And that doesn't happen when you move from Java to .NET or vice versa. So where I'm going with this is that to get the full benefits of Agile can take time. It's a big thing. There's a lot to Agile. Often people think Agile is just nimble, and we need to be more flexible or something. But actually, if you think about it, there's a whole sort of course curriculum, if you will, of various Agile topics like continuous integration, multi-stage continuous integration, Scrum, Kanban, extreme programming, which is not just pair programming, incremental design. There's a whole book on incremental design. There's a whole book on refactoring. There's a whole book on Lean. There's a whole book on Scrum, on Kanban, etc. There's a lot of material here. There's a lot to learn. Now, you don't have to know it all to getting the benefit. Right? You get the benefits as you go. You start implementing some of these things. You start implementing unit tests and refactoring and continuous integration. But in my experience, a lot of people just do not invest in the training that they need. And unfortunately, some of the training out there is a little expensive. CSM, Certified Scrum Master, is one of the only ways to get an introduction to Agile, and that's $1,500 per person retail. And it's a 2-day, takes 2 days out of your time. So while fantastic, it can be a little expensive and time-consuming. So one of the things that we offer is the Scrum Team user training, where we can come on site and we have some public ones. You can see our website. It's 1 day. It covers Scrum and other Agile topics. We get into some of the technical practices. Anybody can show up. It doesn't have any requirements or assumptions about your level of knowledge of Agile or software development. It's a great way, very affordable way to learn about Agile. And then
awesome.
The other point I was alluding to there is that this is going to be a long-term investment, and you want to look at things like coaches and training in general.
Some very important advice for those out there. Well, I think we're going to close on that last remark. Damon, I want to thank you very much for joining us again today, and I want to thank our audience in attendance as well.
All right. Well, you're welcome. Thank you for your time as well. I think that was fantastic.
Again, we do have the contact information for AccuRev up on the screen there. If you have any more questions for Damon or want to check out the product, do be sure to check those materials out. Again, we want you to be able to check out the rest of the community today. Oh, 2 questions I think are actually coming in, and we do have time. Damon, if you're ready to answer a few more here.
Sure. Yep, absolutely.
I apologize for...
I've reserved time for at least another 10 minutes.
That sounds good to me. I apologize to everyone for attempting to cut it out early there. Because we do have a follow-up question to one of the previous as well. So the first statement for you, there are many continuous integration tools from open source and commercial products. Which one, in your opinion, integrates well, does integrate well with AccuRev's product?
That's a great question. Let's see. So we didn't actually write any of the integrations that are out there. Those have all been contributed by our partners and the open source community. I believe we have customers using pretty much everything that's out there, from Cruise Control to Anthill Pro to Electric Cloud to Hudson. We actually resell Anthill Pro as part of the Agile Cycle suite, and so that's probably where we, I would say, put the most effort as far as new stuff goes, but then that generally rolls into the other integrations over time. Let's see. I would say that in our customer base, most folks are using either Anthill, Cruise Control, Hudson, and then beyond that, I would have to check with somebody here. But those are the ones that folks are using the most. And I know folks are having success with others as well, but those are the 3 that we hear the most.
That's wonderful. Hopefully that gives a good answer to that question. Now, I believe our last question so far is a follow-up to the geographical or the geography-based question from earlier. If AccuRev itself has a central approach or also uses cache mechanisms distributed over the development sites. Actually, I might be skipping the question there, but
I've got that one. I've heard that question before in various forms, and so I understand now a little bit better about what the caller was asking earlier. Thank you very much for the follow-up. So the person asking the question is basically looking to how did we implement, what's sort of the architecture for how we do geographical development with AccuRev SCM. Okay, great question. Excuse me. So there's a couple of different approaches out there today, right? You've got the clear case multi-site approach, which is bidirectional, read-only replication. You can do reads on one side and writes on the other, but not writes on both sides for a particular branch. You've got centralized, where there is no replication, there's no caching, no anything. Basically, you are using that connection to go back to the main server. You've got proxies, you've got caches, you've got all kinds of stuff out there. You've got one of the newer things out there is distributed version control, which is using peer-to-peer replication. Excuse me. So these are all different ways to try to solve the same problem. One of the things about what is called DVCS, distributed version control, is that there's a couple of different benefits that come from that system, and often they're put together as the same benefit. So, for instance, in something like Git, folks tend to say, oh, I like the fact that it's distributed, and I like the fact that I get private branching. Well, you don't actually need Git to have private branching, for instance. So in AccuRev, you definitely get the private branching without the need for the peer-to-peer replication. And so there's pros and cons, pluses and minuses to both approaches. What AccuRev uses specifically is that by default, you can set up, and it's very efficient, and it was always designed for working over the internet, a centralized repository. And a lot of our customers find that the performance of that is fantastic. However, we have some larger customers and even some small customers that are doing a lot of distributed development and sometimes doing distributed development of very large files and that sort of thing, so more bandwidth required. And for that, we use something called AccuReplica. AccuReplica is unique in that you get, for any read operations, you're getting local access because anything that you need is going to be kept locally, including the metadata. So if you're browsing around, you're doing history or annotate or diff, all of those operations are going to be run at a local site and run at local speeds. So there's no difference there between, say, something like Git and AccuRev from that perspective. For write operations, those operations are going to go back to the master, and that's going to be a little slower than the read operation, but a write is something that you do infrequently versus a read, which is something that you're getting changes from a lot of other people all the time. So we use a combination of a complete up-to-date mirror for the metadata and a proxy cache for the actual file contents. And our customers tell us that that works very well.
All right. Well, I appreciate you being able to pick the question out of what I was able to tell you. I think due to the false ending before, I think we're going to end now after this last question. We're very glad to have that follow-up, and we're thankful again for everyone joining us today. We hope you enjoyed the broadcast. Damon, thank you again for a great presentation and question and answer period.
My pleasure.
We want to be sure to see everyone at our next broadcast. In the meantime, be sure to check out all the community features we have available for you, including the latest edition of the Agile Journal, the forums, and our featured articles section. So do browse around, and we look forward to seeing you in the near future.